Okay, this is what we're looking at, just some advice in terms of things like this. If you've got something that involves a function or equation or a graph or something like that, and they ask you for intercepts for how many times it crosses a line or something like that, in this case we're being asked for the range of this function. My advice to you people is to graph that thing. So we're going to define this function and we're going to define it over this domain. So what we're going to do, we're going to say, whoops, wrong one. Where is Cas? There it is. So we're going to say define f of x equals, and it was 6x minus 1, 6x minus 1, and then we do given. Now, can I make that bigger? No. So I've got to use the thing here above equals. So you can't see it, which is that there. So that's the one, control and equals. Given, now we check our domain, -1 to 3. So it's, we use the same key, so it's negative, where -1 is less than x, which is less than or equal to 3. Let me just check that. Yeah, and I'm going to press enter. And then I'm going to graph that. So I'm going to say, I'm going to go to here, I'm going to graph that, and I'm going to say, let's graph f of x. And there it is. Now, not the best thing there, so I'm going to zoom out, there's the center, and then I can see, I've got an idea as to what they are, so I may go analyze graph, maximum, so lower bound, up bound, so 17 is my maximum. So I've got it here at -7 and 17. It's the only option there, so that's what I'd be choosing there. Okay, so that's that question done. Let's see if there's any others. Here we go, here's a good one. The solution to the quadratic equation, this equals 0r. So what we do is we would say, so if you're given something like this, then we could say home, solve, type in the equation, -2x squared plus 5x minus 3 equals 0 for x. It's telling us at 1 or 3 over 2, and here it is at 1 or 3 over 2. No, what else have we got? Points of intersection, that's one of the success criteria. We want to see where these two intersect. It originally says linear, so let's just check the success criteria. Here it is. I can solve linear equations. I can find, there's one here, I can graphical tools, determine where two graphs intersect. So we did that a number of ways. We can either do that graphically or with solve. So let's try these two. So we're going to say solve, and we're going to say 2x squared plus x minus 1, 2x squared plus x minus 1 equals 2x. So we're solving that for x. Press enter, and we get -½ or 1, and it's one of these ones here, -½ Oh, hang on. Oh, no, we've got coordinates. So -½ and 1. So that's what it ends up being. So what we can do is we can say, substitute this 1 into one of the other ones. And so we could substitute 1 into this. We end up with 2. And there we see 1 and 2. So that's point of intersection. What else is there? Equation to the parabola. There's other videos that explain how to do that. If you've got something like this, which says we've got here's an equation, then we want to find it. And what form is this? Well, it's turning point form. So we complete the square. But I think there is a complete the square thing available to us. Let's see, menu, algebra, complete the square. We'll try that again. Menu, algebra, complete the square. So complete square, and we type this thing in. 2x squared minus 4x, 2x squared minus 4x plus 3. And I think I'll close the brackets. I don't know if use this. Let's have a look. Too few arguments. Maybe we need a comma x. So there we have 2, then we get x minus 1 plus 1. And so we've got h at 1, h will be 1, k will be 1. So that's what we end up with there. Okay. Now let's see if we got something a little bit different. Okay, if the graph of y equals x squared plus 2x plus k has 2 distinct x-intercepts, then we're looking at this. So this would be using the discriminant. So for that, I'll say, do we have a discriminant thing at all? Let's see, algebra, numerical style, polynomial tools, real fine roots of a polynomial, complex roots of a polynomial, equation of polynomial, greatest no. Let's see. Change complex, extract. No, we don't have anything there. So it'll be a case of so we know it's negative b, so it's b squared, so 2 squared minus 4a, which is 1k. So then that's what we end up with there. So then we let that equal 0. Solve equals 0 for k. So k is equal to 1. So if k equals 1, then we've got 1 intercept because the square root equals 1. So k has got to be greater than 1. So k has got to be greater than 1. So there we go. It ends up being D. Once again, here's a good one. The graph of this has asymptotes with equations. So what we do, we graph that. So we've got home. We graph that. Tab -2 divided by open brackets x minus 2 all squared, and then we have a plus 1. Whoops, I graphed it by accident there. Plus 1. So there we can see we've got an asymptote at 1, and then we've got another one here at 2. Once again, we're asked for a domain. So the maximal domain of this thing, we just graph it. So I'll graph that, tab, delete this thing because I don't need it anymore. And I'm saying the square root. So square root of, what is it, 3x minus 1 is what it is? Oh no, x minus 3 plus 1. Couldn't have been more wrong. X minus 1 plus 3, actually it could have been more wrong. X minus 3 plus 1, I've got it. X minus 3 plus 1. So there we go, so we look at that. And then we say, well, clearly the endpoint there is a minimum, so we'll go analyze graph, minimum between those 2 points. Oh no. Undo that. Analyze graph, minimum between here. Oh, somebody's not picking it up, but it looks like the minimum happens at x equals 3. And then from there, we just say that, okay, so it's 3 out to infinity, because that's what our graph is clearly doing if we scroll around, because that's exactly what it's doing there. We've got a graph there. If we've got this is our using our remainder theorem and our factor theorem. So if we're dividing by this thing, then we need to define this thing here. So we'll say, get a new one. Define f of x. Try g of x over e of x. So x equals x cubed plus 2x squared minus 6. Okay, that's what we're doing. And then now this thing here, 2x plus 4. Okay, so then with this thing, we've got to let this now equal 0. And then we'll see that's what we're going to substitute in. So if we've got 2x plus 4, so if we've got 2x plus 4 equals 0, so that's what we've got there. We're going to subtract 4. Whoops. We're going to take, subtract 4 from both sides. So we end up with that. Now we're going to divide both sides by 2. So that tells us x equals -2. So then we're going to say g of -2. This is our remainder. So this ends up being -6. There we go. That's how we go about finding a remainder. If x plus 2, if x plus 2 is a factor of p of x, then, so we end up with this, so if x plus 2 is a factor of some polynomial, then p of 2 equals 0. That's just what we know. Oh, sorry, no, p of negative 2, because whatever we've got here, positive, should be negative. I think that's about it for now. Uh, 17 green balls, 12 white balls, 23 red balls, probably randomly balls selected is not green is closest to. We got that. I think this might be it. Okay, that'll do for now. I'll see if I can find some other ones that may be applicable to give you some more information.